Okay, so for 7.2, second part, let's continue on with example number 6. Example number 6 looks fairly innocuous. It's not that easy. We have cotangent of 7x dx. Okay, well, I mean, you can just look it up, I would assume, right? Just look it up. Or, so the way we're going to do it is this. We're going to say, what is cotangent? Cotangent is cosine 7x over sine 7x dx, right? Okay. So I'm never going to find something that goes like this, correct? Dx over sine x, sine 7x, right? But I could get this, right? I could get this if I took the derivative of sine 7x, right? I could get something that includes this with a number, right? So if I had u is equal to sine of 7x, I take the derivative, I get du. This is going to be cosine 7x dx, but then I have to do the chain rule, so that shows up, right? In other words, I get this guy as being that, right? So what do I got? I got 1 over u, and then I have du over 7. 1 over sine x, sine 7x, right? So that's where the 1 over u comes in. So I'm going to pull this 1/7 out. Go like that. So this is going to be equal to 1/7 natural log of u plus c, right? Because I take the derivative of this guy, I get this guy right here, right? There you go. That's your answer. Pretty weird, huh?
Yeah.
Pretty weird that you would get this. Uh-huh.
Why did you make it you and then make it not you again? Like halfway through.
So I got the u in there, and so u, this allows me to do the easy anti-differentiation right here. And then since I'm not looking at u, I want x. I have to put it back into x. That makes sense?
But you could, in this problem, you could just leave it as sine 7x, right?
What do you mean?
Like leave the denominator, like where you substitute u, leave it as sine 7x, and you end up with the same thing.
I would end up with the same thing, yes. But it's not immediately obvious to me what's happening. When I go like this, I know exactly what I'm doing. Okay, and that's what I meant by being deliberate, being step by step here. Okay, if you try to jump steps, again, this is where you're gonna make mistakes. Okay. I'm not jumping steps. Okay, so that's that. Example number 6. Let's go to example number 7. We get some interesting stuff in example number 7.
Oh my god.
We get some trig stuff. That's everybody's favorite trig. And we have 1 over cosine squared 2x dx, which is really the same as, if you put it like this, I don't know what's going on. But once I go ahead and make this to this, oh, okay, now I got something going, right?
Oh.
Right? Because secant square, what the anti-differentiation of a secant square is what? Tangent, right? It's tangent, right? So, well, except I got the 2x here, so let's kind of get rid of that. So I'm going to set that like this. du is equal to 2 dx, which means that this guy is that. So I'm going to get what? This is going to be secant squared u right? Because u is this. Then I'm going to put this guy, I'm going to put this guy instead of that. So it's going to be du over 2. Right? So I'm going to pull the 2 out. And this is nothing more than tangent u. So I'm going to get 1/2 tangent u plus c 1/2 tangent 2x plus c.
All right.
Okay? Yeah. I'm just taking the derivative of both sides here. Right? Take the derivative, I get du. Over here, I take the derivative of this, the x goes away, and I get 2 dx. Okay? So this one wasn't too bad.
Just
The second one is not good at all. The second one is not good at all. The second one brings up, yeah, cotangent stuff. Like, what the heck? Who does cotangent, right? Cotangent. Not only is it cotangent, it's cotangent squared 3x dx. Okay. So I know nothing about cotangent, but I do know my trigonometry says this is the same as cosecant squared 3x minus 1 dx.
if you remember.
Okay, so everybody remember how we start from here. It's equal to 1, right? I'm going to divide everything by sine squared. 1 cosine squared over sine squared is going to be cotangent squared. 1 over sine squared is cosecant squared x. So this is where I got this from, right? Because if I move this over, right? This is eons ago, I know. It's 2 years ago. Actually, a whole year ago for you, right? So here we go. So this is where we at. Okay, this is where we at. So why is this good? Is because if you go to back to page 341, lo and behold, there is a cosecant squared u du thing right there.
That's so nice.
It's a minus cotangent u. Okay, so let's go get rid of the 3 x's. Okay, exactly. I did. So that means that this is probably not going to be on the test.
Oh,
Something using
whoa.
this.
I think that's the,
Using this.
that's the first time he's ever said this won't be on the test.
So if I do that and I put that in there, what do I get? I'm going to get cosecant squared u minus 1. You divide this by 3 du over 3. I'm going to pull that 3 over here, just like that. 1/3. This is going to be negative cotangent u minus u plus c. Right? But then I have to 3x. 3x. Okay. That's what that's going to look like. Okay, the last one is this is more doable for you guys because it doesn't require you to know this obscure trig relationship. This is something you can deal with better. Cosine cubed x dx. Okay, so normally when we did substitution, we would have something here, and then I take the derivative of that, and there was another part that can go with this, right? But I don't have that. I don't have that, okay? So what we're going to do here is we're going to go ahead and call this cosine squared x cosine x dx. Then I'm going to go ahead and go 1 minus sine squared x cosine x dx. Now, if I call sine x u, I take the derivative of what do I get? If I said u is equal to sine x, I take the derivative of both sides, I'm going to get cosine x dx. So in other words, da-da, there it is right there. All right, I found that guy. So I can say this is going to be equal to 1 minus u squared. And this guy here is du. So I'm going to get u negative 1/3 u cubed plus c, where u is equal to sine x minus 1/3 sine cubed x. This is not easy, yeah, but I would say easier than B. Easier than B is what I would put it.
Well, it's easier than it look, right?
Oh, okay,
Yeah,
okay.
it all makes sense, but it's like, how would you come up with the idea?
Exactly. Again, and this is what I told you before, right? It's not necessarily the mechanics that you're interested in. It is the why behind the step. Right? It's the why did I do it that way, right? Okay. Does it make sense? Kind of. When I go from here to here, how I go from sine, now when I have to the derivative of sine, I'm going to get the cosine, so I can get cosine x. All right, so that was that. Now we're going to go back to definite integrals. We're going to go definite integrals, but we're going to do the same thing we're doing here, but there is one step that you have to do. There's one thing that you have to do. Let's go example number 8. Example number 8, I have 10x secant squared x dx from 0, is it, to
Square equals
pi over 3. Okay. So I can rewrite this as what? Oh, so yeah, so this guy is what? If I take the derivative of, what is it? Secant x, what do I get?
squared.
If I take the derivative of secant x, so if I take the derivative here, du, what do I get here? Isn't it secant tan?
Yeah.
Well, look at this. What did I get? I got that whole thing. Ooh, double whammy.
Put it backwards.
You see, I get the double whammy. You get 2 of these here. So I'm going to go from, so here we go. I'm going to get, this is going to be what? Just u, right? And this is du. Okay, so now here is the part where you're going to, this is the part where you're going to miss. This is the part where you always miss. This is the part that you do not do what you're supposed to do. And this is that you had the boundaries. The boundaries are in what? Values of what? They're values of x, right? X's are these, right? When x equals to 0, x is equal to pi over 3, right? But now I'm dealing with u. So when x is equal to 0, right? What do I get? When x equals to 0, cosine is equal to 1, which means that this value is going to be 1, because it's the u value. It's the corresponding u value for when x is equal to 0. The corresponding value when x is equal to pi over 3 would be what?
Count the finger.
Cosine pi over 3
1/2.
is 1/2. So 1 over 1/2. 1 over 1/2 is 2.
That's not.
So this is the one that you're gonna, what?
The book says you're wrong.
Who says I'm wrong?
Yeah.
do it a little differently.
It
They
says
did
0
use
to
the
root 3.
hand- or the-
Because they use.
Oh, they did it that way. Okay, well, still, you should get the same thing.
Mr. Ron is better. Mr. Ron doesn't need the book.
Right?
Wait, where's that from?
I have definite, it's definite integral,
Oh,
right? It's definite integral, right? So it's gonna be 1 and 2, I get 2, right? Because it's 4 over 2, right? And I have to subtract the 1 value, which is,
oh.
oh, hey, so the book is right.
Well, Mr. Ron was so
Yeah,
much
they just went about it a different way. It's the same thing though. Okay. Now, the good thing about this is that you do not have to replace,
How did you use it?
because when u is equal to 2, I get 2 squared is 4. Right? Okay.
All right. Then
Okay, I am not gonna do 9 with you because I think I see a lot of eyes rolling. And I don't think it's gonna be that effective. So we're gonna call it a day here. I do want you